Welcome to The Explainer. Today, we're diving into a student project that asks a really bold question. What if AI could help us figure out why we're sick? You know, that really personal, often stressful part of medicine?
All right, let's get right into it. Think about it. We've all been there, right? You've got a cough, maybe a fever, some aches, and you start playing detective, trying to figure out what's going on. Well, this project poses a really interesting question. What if a smart system, an algorithm, could piece together those clues for you? And that right there brings us to a major hurdle in modern healthcare, what you could call the diagnostic dilemma. I mean, getting the right diagnosis and getting it fast is everything. It's the first step to getting better. But as we all know, it's rarely that simple.
And this quote from the project's thesis really hits the nail on the head. It's not just about being annoyed that you don't know what's wrong. A slow or wrong diagnosis, that's a big deal. We're talking about delays in treatment, which can lead to much more serious complications down the road.
Okay, so how do you even start to tackle a problem that big? Well, that's where this student's final year project comes in. The idea? To build an AI-powered system that can actually classify diseases just by looking at a list of symptoms.
So, the project we're talking about is called the Disease Classification System. It was created back in 2023 by a student named Ashish Podal for his degree at Tribhuvan University. This isn't just some abstract theory either. It's a fantastic example of how students and researchers are trying to build real, practical tools to help out in healthcare.
So, the project had three main objectives. Pretty straightforward. First, use a specific machine learning algorithm, it's called Naïve Bayes, to basically connect the dots between symptoms and diseases. Second, build a web interface that's super user-friendly, something anyone can navigate. And finally, the big one, create a tool that could actually help healthcare professionals make better, faster decisions. Okay, so that's the what. Now for the how. How in the world does a piece of code predict a disease? Let's pop the hood and look at the engine of this thing, the Naïve Bayes algorithm. At its core, Naïve Bayes is just a probability machine. It's all about calculating chances. You give it symptoms, and it tells you the likelihood of you having various diseases. Now, here's where the naive part comes in. The algorithm makes this naive assumption that every symptom is completely independent. It's like saying that having a cough has absolutely nothing to do with also having a fever. We know that's not true. They often go hand in hand. But this little simplification is exactly what makes the algorithm so fast and, believe it or not, so effective.
Let's break it down with a super simple example from the thesis. Is it the flu or just a cold? So, first, the system looks at its training data and asks, in general, how common is the flu versus a cold? That's its baseline. Then, you tell it you have a cough. It calculates the probability of having a cough if you have the flu and the probability of having a cough if you have a cold. It does this for every single one of your symptoms, multiplies all those probabilities together, and voila, the disease with the highest score at the end is the one it predicts.
Okay, so that's the theory. It sounds pretty cool, right? But the real question is, does it actually work? Let's move from the code to the clinic, so to speak, and check out the actual results and what the final product looks like. So you might be asking, why Naïve Bayes? I mean, there are tons of other fancy algorithms out there. Well, the student didn't just pick it out of a hat. The research pointed to a study summarized in this table. They tested several algorithms on 15 different medical datasets. And guess what? Naïve Bayes came out on top in 8 of them. That's more wins than logistic regression, decision trees, and even complex neural networks. Pretty impressive for a naive approach, huh?
All right, the moment of truth. What was the final score? The model achieved an accuracy of 79%. Now let's put that in perspective. It means that nearly 4 out of 5 times it correctly identified the disease based on the symptoms it was given. For a student project, that's not just good, that's a seriously strong proof of concept.
But accuracy alone doesn't tell the whole story. We got to look a little deeper. The precision was 78%. What that means is, when the system said, hey, you probably have the flu, it was correct about 78% of the time. Then there's recall, which was 70%. This means that out of all the people in the data who actually had the flu, the system successfully caught 7 out of 10 of them. The F1 score, which kind of balances these two, landed at a solid 74%.
And here's what it all looks like for an actual user. No complicated command lines or anything like that. It's a clean, simple web application. You literally just log in, punch in your symptoms, and the system gives you back a potential diagnosis. It's all designed to be super straightforward and easy for anyone to use.
So a 79% accurate model and a working web app.
That is a fantastic starting point. But, this is just the beginning. The really exciting part is thinking about what comes next, and the project itself offers some awesome ideas for the future.
The developer laid out a few really powerful next steps. Just imagine, what if the system could also recommend potential medications based on its diagnosis? Or what if it kept a history of your past illnesses, making it smarter and more personalized over time? And here's the holy grail. What if it could plug directly into a hospital's electronic health records? That would be an absolute game changer for doctors.
But let's take a step back and be realistic for a second. There are limitations. The project itself is clear about this. Any AI, and I mean any AI, is only as good as the data it's trained on. If you have incomplete data, or if you don't have enough examples of rare diseases, the system's accuracy is going to take a hit. That's one of the biggest hurdles for this kind of technology to overcome.
So, what's the big takeaway here? This student project gives us a really powerful glimpse into a possible future. A future where AI could be a valuable first step in our healthcare journey. It's not about replacing doctors, not at all. It's about giving both us, the patients, and the medical professionals better information and getting it faster. Which leaves us with a pretty fascinating question to think about. Could your next diagnosis actually start with an algorithm?